this center of gravity for a particular area. So next we will calculate what is this center of gravity of an area. Now suppose you have this area, some curve is given to you and this is the area, right? Now in this particular area you would have certain points, in fact in infinite number of points here, right? So what you can do, you can also treat this to be a bulk quantity having infinite number of points in it, so that we can calculate the center of gravity for this area, right? So for this we also assume that rho represents the mass per unit area, then the mass of this elementary area would be rho into del A. Suppose I take some small portion out of this area, say this is delta A. So if this rho represents mass per unit area, so what would be the mass of this particular region? It would be the area delta A multiplied by rho. So this would be the small mass. Therefore the coordinates for center of gravity would be x bar comma y bar. So it would be integration x into whatever mass we have divided by the total mass, and this y coordinate would be, it would be integration of y whatever mass we have divided by this the total mass, that is the integration of this delta m. So now we will substitute directly the value of this delta m, that is rho del A. So it would be x rho del A divided by rho del A, and what would be y coordinate? It would be integration y rho del A divided by integration rho del A. So this is one formula. Now suppose that rho is given to be constant. So that means this mass is not changing when you change the position. The mass over here would be same here, would be same here, would be same here. So it is remaining constant. So we say all through this particular region, the mass of the object is constant. So we say it has uniform area. So in that particular case, your x bar would simply be integration x rho A, x delta A divided by delta A. So this delta would also change to dA. Why? Because now we can take a little more portion out of this dA. And what would be this y bar? This would be integration y dA divided by integration dA. So this is the formula that we have now. Now let us see the next case. So case number 1. Now suppose the area is defined. This area is defined in such a way that it is bounded by y is equal to fx, the x-axis, and the coordinates x is equal to a and x is equal to b, right? So what kind of area we would have? So suppose this is the curve, this is x-axis, this is the y-axis, this is the point x is equal to a, this is the point x is equal to b, then our area would be this portion, this whole portion. So out of this whole portion, now if I take this small strip over here, this is very small thin strip that I am considering. So now I am assuming its area is nothing but this delta A, because this is a very small area. So what is this length? If I have some point here as x comma y, so its length would be y and this is the very small displacement in x, so it would be delta x. Therefore, delta A would become y into delta x. This is one thing. Moreover, for this particular thin strip, what are the coordinates for center of gravity? So the coordinates here, center of gravity would locate somewhere here. So suppose this total length is y, and at this point we have x, right? Because this point was nothing, x comma y. So the coordinate of this point, they would be, x would be as such, and the coordinate, y coordinate would be y by 2, because if the total length is L, so this much length is y by 2, because the center of gravity would lie exactly at the half portion of it. So now let us see what do we have. So this thing, what does it become now? So our x bar, which previously was integration x dA, integration x, what is dA here? dA is y dx. So our dA is y dx divided by integration y dx, right? And the y coordinate would be integration y dA. What is dA? According to this formula, what is dA? dA is this quantity. It is y into dx divided by integration y into dx. And what is this coordinate? X. And what is this coordinate? Y. Whenever we have the center of mass for this particular strip, the coordinates of x would be x only. So it would be x bar would be x y dx integration divided by integration y dx, and y bar would be, here the coordinates of y will change to y by 2. So it will be y by 2 into y into dx divided by integration y dx. So what we got from here is, we get integration xy dx divided by integration y dx, and it is y square by 2 dx integration divided by integration of y dx. So this is what we got whenever our area is defined and it is bounded by these x-axis, the coordinates x is equal to a and b, and the curve y is equal to f of x. In the second case, case 2, when the curve is given to be x is equal to f of y, and it is bounded by the y-axis and the coordinates y is equal to a and y is equal to b. So your curve here would be like something like this. So its equation would be x is equal to f of y, and say this is the point x is equal to b and this is the point x is equal to a. So our total area would be this one. So this whole is the total area. And now what we can do, we can take a very small portion of this area. So we can take very small strip over here. So this strip we have considered. So now this strip, for this strip, what would be the area? The area for this strip would be this side multiplied by this side. So what is this side? Small increment in y. What is this side? This is x. So we have x into delta y. So what would be corresponding dA? dA would be x dy. So this is small displacement over here, and corresponding to this particular strip, this is very thin strip. So what would be the coordinates for center of mass? So its coordinate, the coordinate for this point would be, say, x comma y. Then the coordinates for this point would be x by 2 comma y. These are the coordinates where your center of gravity would be located, right? So for these coordinates, if I use this formula for the center of mass, so what do we have? we have x bar, that is integration of x, the value of dA. dA is x dy here, divided by integration the value of dA, that is x dy. And if you see the formula for y bar, so that was integration y dA by integration dA. So it would be, so this is equivalent to integration y dA. dA is x dy divided by integration of x dy. So now the next task is to substitute the value of x and y here, because we wanted to calculate this for the center of mass. So x bar would be integration x by 2 square dy divided by integration x dy, because in place of x we have now substituted xy, and in place of this y, because y is remaining the same, so we would have yx dy divided by x dy. So these are the coordinates when you are calculating the area for this curve. X is equal to f by y axis and y is equal to a comma y is equal to b. So let us discuss one example. The question says, find the center of gravity of the area under one arc of the sine curve. Y is equal to sine x. So now you have to see which formula you would use for this particular question. So for the solution, firstly we draw this curve y is equal to sine x, and they are saying the area under one arc of the sine curve. So you know the graph for the sine function, it is like this. It is oscillatory in nature. But because they are saying it, calculate it for one arc, so that means we'll only go up to this point. So our graph would be like this, not this, but this, right? So this point is 0, 0, and this point is pi. If this represents x, this represents the angle, and this represents sine of this angle, so sine of the x. So then we have pi comma 0, because the function's value here is 0. So these are the limits under which we have to calculate our center of gravity. So what would be the center of gravity for this point? So x bar would be the formula that we'll use, y bar would be the another coordinate of y. So what would be the formula for this one? Here we'll assume that the area is uniform. So we'll ignore the quantity, we'll ignore rho. So what would be this x bar? It would be, now you have to see, this is symmetrical about, this is given, this area is bounded by this x-axis and the curve y is equal to sine x, and the points x is equal to 0 and the points x is equal to pi. So we'll be using which formula? This case, so we'll be using this formula. So x y dx, and here we would have y square by 2. So our formula here would be, this would be integration x y dx divided by y dx, and the limits here would be from 0 to pi, because the region here is bounded, right? And the coordinates for y would be integration from 0 to pi and y square by 2 dx divided by integration from 0 to pi y dx. So let us simply calculate this. So wherever you see y, you will just replace that by sin x. So it would be integration from 0 to pi x sin x dx divided by integration from 0 to pi sin x dx. So we can solve this one. So let us first solve this one. So it would be So x coordinate, that would be integration from 0 to pi of x sine x dx divided by integration 0 to pi sine x dx. So firstly, its integration, calling this to be the first function, second function, so it would be first function as such, integration of second minus integration derivative of first, integration of second, and here the limits varies from 0 to pi, and in the denominator its integration would be minus cos x, limits varies from 0 to pi. So you can solve this one, right? So it would be pi into minus cos pi and then 0, and then we have plus integration of cos x is sin x, and its integration limits varies from 0 to pi, and here we have minus cos pi and plus cos of 0. So what would it be? The value of cos pi, it is equal to minus 1. So we have pi here, and the value of sin pi is 0, sin 0 is 0, so we have pi here. And here we would have the value of cos pi is minus 1, so it becomes plus 1 and plus 1. So we have pi by 2 here. So this is the value of for x coordinate. For y coordinate, we have integration from 0 to pi. The value of y is sine square x divided by 2 dx, and then we have integration from 0 to pi sine x dx. So now you can perform this integration. So what would it be? It would be y bar, that is integration from 0 to pi sine square x, 1 by 2 would be taken out, dx, and then divided by integration 0 to pi sine x dx. So it becomes, here you would use this formula, double angle formula, and then perform its integration. So it would be, its integration would be minus cos of x, and the limits varies from 0 to pi. So in the denominator we would just have 2, and in the numerator 1 by 2 would again be taken out, so it would be x, and then the derivative of cos 2x would be minus, it would be sin 2x divided by 2, and the limits varies from 0 to pi. So it would then be 1 by 8, and then we would have pi minus sin 2 pi divided by 2, and then the lower limit would be 0 minus 0, right? So sin 2 pi is again 0, so we have pi by 8 as this answer. Therefore, the coordinates for center of gravity, they are pi by 2. They are basically this x bar comma y bar, and what is the value of x bar? We have it to be pi by 2. So we have this to be pi by 2 and pi by 8. So this is the final answer.